Good day, everyone. Today is 15 June 2020. I hope I am speaking to SS2 chemistry student. Having discussed oxidations and reduction, that is redox reactions, we are able to discuss oxidation reduction in terms of addition of oxygen and removal of oxygen, in terms of removal of hydrogen and addition of hydrogen, in terms of electron transfer, and in terms of oxidation number. We're able to identify the oxidizing agent, the reducing agent, the oxidized, and the reduced. Alright, and I've marked your assignment. Really, you people did very wonderful. Your expression was very nice. I encourage you to do more than that. Lay your hands on relevant questions and then solve them. Okay, today we will look at balancing redox equation by half reaction. Balancing redox equation by half reaction. Alright. One of the uses of oxidation number is balancing oxidation reduction, that is redox reactions equations. And in these redox reactions, just like we have discussed in the oxidation reduction, that if the two elements or compounds will combine to give us a product, one of them will have higher oxidation number, so that the transfer of electrons or transfer of atoms will be possible. The same thing with these redox equations. If elements are combining, one of them must be oxidized, the second one will be reduced. So there must be a transfer of electrons from one element to another, or from one compound to another. Alright, that this redox equation, a redox reaction equation can either be simple or complex. It is termed a simple ionic equations if all the ions in the equations contains atoms from single element. Atoms from single element, like if you have just copper metal reacting with the silver ions to give us copper ions and the silver metal. They are single atoms from single element. That one you refer to them as simple ionic equations, and is also termed a complex ionic equation if two or more atoms from different elements forms ions. That means if maybe you have your copper sulfate and reacting with maybe silver nitrate, that one is a combination of elements to form ions. That one is a complex ionic equations. Balancing redox equation depends on two important factors. That is, one, types of ions, whether simple or complex ions. Then secondly is nature of medium, whether neutral, acidic or alkaline. Neutral, acidic or alkaline, where these ions will take place. Okay, we'll look at to balance simple ionic equations. In order to balance simple ionic equations, the following 5 steps are considered. Example, the reaction between copper metal and solution of silver ions. Here we have copper metal and then aqueous silver. In this reactant, this one is solid while this one is aqueous. This silver has already lost its electrons to one element which you don't know, but it has come to undergo a reaction between itself and the copper. And when they react, they produce these copper ions and silver metal. It means this copper gain electrons from silver to form this. In these equations, copper reacting with silver ions to produce copper ions and silver metal. Silver has already given its electrons to someone which we don't know, but has come to react with this copper to collect electrons from copper to itself. So copper has agreed to do that, and here is the product side. Now copper is carrying 2+, meaning it has given 2 of its electrons to silver. Now silver has received the electron and becomes a silver metal. This is silver metal. You see that this one oxidation number here is 0, here is 2, this is oxidation, and this one oxidation number is 1, and here is 0. This one is reduction. Remember, losing of electrons will lead to increase in oxidation number, and that is oxidation, and gaining of electrons will lead to decrease in oxidation number, and that is reduction. The steps to consider, we have step 1. In this ionic equation, separate chemical species undergo changes into two half fractions, that is copper ionized to produce copper ions, that is oxidation because there is increase in oxidation number, and silver now collect these two electrons released by this copper to itself to form silver metal. Then step 2, balance each half reactions mass-wise by conforming with the law of conservation of mass. That is, the law of conservation of mass has been studied that a matter can neither be created nor destroyed, but it can be converted from one state to another. This is copper metal and copper ions. You've converted this one from metal to copper ions, but the mass still the same. This one is charged, not mass. So 1, 1. But has been converted from metal to ions. The same thing with this. This is silver ions being converted to silver metal. It has proved the law of. Then step 3, balance each half reactions charge wise by adding appropriate number of electrons to either the left or the right, hand side of the equations. And this copper metal, when it ionizes, it releases 2 electrons. Here is the 2 electrons. It releases 2 electrons when it ionizes. Here is the 2 electrons. Now silver ionized. This ionized silver now gain 1 electron to form 1 metal of silver. So this one needs just an electron to form this metal, while this one will ionize 2 electrons to form this copper 2 ions. Then step 4, multiply each half fraction by the appropriate In step 4, you multiply each half fractions by the appropriate coefficient to balance electrons lose or gain. That is, this copper is equation 1 here, and silver is equation 2. What you will do to balance these oxidations and reduction equation is you will multiply equation 1 by 1 electrons of silver and multiply equation 2 by 2 electrons of copper ions, so that you have 1 times this will give you this, 1 times copper ions will give you copper ions, 1 times these electrons will give you these 2 electrons. Then in silver ions we have 2 times silver ions will give you 2 silver ions, 2 times this electron will give you 2 electrons, 2 times silver metal will give you 2 silver metal. That means they have equal number now, meaning if one copper will release 2 electrons, we need 2 atoms of silver to receive the electrons. If copper will release 2 electrons, we need 2 atoms. One atoms of copper will release 2 electrons, and we need 2 ions of silver to collect the electrons to form these 2 silver metal. Then step 5, combine the 2 half fractions and combine the 2 half fractions and multiply the equation, verify the equation. In this step 5, you are meant to combine the 2 half fractions and verify the equation if it is balanced, both mass wise and charge wise. And then you now have copper metal plus 2 silver ions to form copper ions and 2 silver metal. The equation is balanced charge wise and mass wise. 2 moles of silver ions, 2 mole of silver metal, 1 mole of copper metal, 1 mole of copper ions. Example 2, you follow the 10 steps. You now arrive at this magnesium. 1 magnesium plus 1 atoms of magnesium need 2 atoms of chlorine to produce these magnesium ions and chloride ions. Follow that example and solve this one. Thank you. The next one we will look at the complex ionic equations.